Hi everyone, so we will now discuss how to solve problems involving the special parallelograms. Alright, so special parallelograms are rectangle, squares, and rhombus. Alright, so let's start with this problem. Two consecutive angles of a parallelogram have measures x plus 30 and 2 times x minus 30. What is the measure of the smaller angle? Okay, so the problem is on consecutive angles. Now take note that by parallelogram property number 3, consecutive angles are supplementary. So therefore, when we add x plus 30 and 2 times x minus 30, they should be equal to 180. That's based on property number 3 of the parallelograms. Consecutive angles are supplementary. Okay, so by the PEMDAS rule, meaning parentheses, exponents, multiplication, division, addition, and subtraction. So we will start with this one here. So we have here 2 times x minus 30. So we have to distribute 2x, and negative 30. So x plus 30, you just copy it, and then 2 times x is 2x, while 2 times negative 30 is negative 60. So we will have x plus 30, just copy it, and then 2 times x is 2x, 2 times negative 30 is negative 60. Okay, so let me erase it first. Okay, so there you go. Now, after this, take note that the left side of the equation can be combined because there are like terms in the left side. So we can add x plus 2x. And we can also add 30 and negative 60. Now, x plus 2x is 3x, while 30 minus 60 is 30, negative 30. So we now have 3x minus 30 equals 180. Now this negative 30 here should be transposed to the other side of the equation so that it will be combined with 180. So we will have 3x. Since the transposition rule says that whenever you transpose some terms on the other side, you have to change the signs of that term. So from negative 30, it becomes positive 30 on the other side. So 180 plus 30 is 210. Just copy 3x. Now 3x we have here 3x equals 210. So next step is of course to divide both sides of the equation by 3. Now 3x divided by 3 is x, while 210 divided by x is 70. Okay, so we just solved for x lang. Now the question is, what is the measure of the smaller angle? However, with x plus 30 and 2x minus 30 as the given, we do not know which of which is the smaller. So we have to start with the first given, x plus 30, for us to know its actual measurement. So we have to substitute the solved value for x, which is 70, on this in this x plus 30 here. So we will have 70 plus 30. Now 70 plus 30 is 100. Alright, so let's do the same thing for the other given, which is 2x minus 30. So we will have 2x minus 30. Same thing. This x here will become 70 because it's the value that we have solved. So we have 2 times 70 minus 30. Now inside the parentheses, we can subtract 70 by 30, and that is equal to 40. So we have 2 times 40 is 80. Now, which of the two 180 degrees is smaller? Of course, it's 80. So therefore, 80 is the correct answer, or the answer to this problem. Okay? So there you go. The measure of the smaller angle is 80 degrees. Alright. Another example is, what are the measures of the parallelogram shaft in meters? So we have this figure. So we have here SOFT, given that 7x minus 1, SO is 7x minus 1, and the rest of it. So from the figure, we know that this illustrates property number 1, wherein opposite sides are congruent. So we can solve for x with the measures given by SO and TF. Now SO, since they are opposite sides, so this side here, so SO is 7x minus 1. By parallelogram property number 1, we can equate SO with TF, which is 6x, in order for us to solve for x. So we have 7x minus 1 equals 6x. Now, we have to transpose 6x to the other side of the equation for us to combine the x terms. So we have 7 minus 6x equals 1. Negative 1 here is also transposed to the other side. So that's why it becomes positive 1. Now 7x minus 6x is x. So therefore the value for x is 1. That's just the value for x. The question here, or the problem here, is asking for the measures of the parallelogram. So therefore, we have to solve for the values of, or the measurement of SO. When SO is given to be 7x minus 1 and x is equal to 1, so by substitution, so x here, x here becomes 1. So 7 times 1 is 7 minus 1, that's 6. Since SO is opposite to TF, therefore we can say that SO is equal to TF. Now when they are equal, that would mean also that TF is also 6. Okay? Our problem now is the measurement of ST. Okay? So to solve for ST, let's erase first. Okay? To solve for ST, just the same, by parallelogram property number 1, so we can equate ST with the given, which is 7x minus 2. Now, since the solved value for x is 1, substitute it, so we can have 7 times 1 minus 2. Now, 7 times 1 is 7 minus 2, so we have ST is equal to 5. Now, take note that OF is equal to ST because they are opposite sides. But then, OF has a given of another variable, which is y. So look at this. You have another variable, which is y. So for us to solve for y, so we can make use of this idea, ST equals OF. So by the given for OF, let's substitute. So OF now becomes 5x plus y. Now, since we have already solved for ST as 5, so we can substitute ST with 5. And similarly, x will be substituted with 1. So we will have 5 equals 5 times 1 plus y. Alright? Now, 5 times 1 is 5. Okay? So then, to solve for y, just transpose this 5 to the other side so that they will be combined with another number on the left side. So we will have 5 minus 5 equals y. 5 minus 5 is, of course, 0. Therefore, the value of y is 0. Now, if the value for y is 0, then 5 times the value of x, which is 1, is 5 plus 0. Therefore, TF is, or OF rather, is equal to 5. Okay? So there you go. We now have the measures of the the sides, which are 6 and 5. So we can now answer the problem with, wait, let me erase first because, okay. So the measures, to answer the problem, what are the measures of the parallelogram soft? So we have the measures of the parallelogram soft are 5 meters and 6 meters. Okay, problem solved. Now let's have another problem. Find the length of the longer diagonal in parallelogram FAST. Now, if we have this figure, okay, can observe the figure properly. Take note that by parallelogram property number 4, we can equate 3x minus 1 and 2x plus 7. Okay, that is to solve for the value of x. Now, after that, we can transpose 2x to the left side and negative 1 to the other side. So that would mean, wait, let me erase it first. Okay, that would mean 3x minus 2x equals 7 plus 1. Now, what is 3x minus 2x? Yes, it's x. And 7 plus 1 is 8. So we have the value for x as 8. Now, the question is find the length of the longer diagonal. So we have to find out what is this 3x, what is this 3x minus 1 equal to? So with 3x minus 1 and with the value of x as 8, let's substitute. So 3 times 8 minus 1. So 3 times 8 is 24. So 24 minus 1 is 23. Now we will check whether they really are equal. So whether 2x plus 7 is also 23. So upon checking, wait, let's do the same process here. So we will have 2x plus 7 and then substitute substitute x with 8. So we now have 2 times 8 plus 7. Now 2 times 8 is 16. 16 plus 7 is 23. So they are now equal. Problem is, length of the longer diagonal ang gi-ask sa problem. So therefore, we need to find AT and FS. Now, since we have 80. The given for 80 is 5.5, which is only half of 80. So we need to multiply it by 2 to get the whole part of 80. So we have 2 times 5.5 is 11. So 80 is then equal to 11. Now, another problem is the measure of Fs. Since we have solved already half of it as 23, so we can also multiply 23 by 2 to get Fs. Now, 2 times 23 is of course 46. So which of the two, let's erase it first. Okay, so now which of the two is longer, 11 or 46? Yes, of course, it's 46. So the answer to this problem is the length of the longer diagonal in parallelogram fast is 46. Okay? Let's continue with this problem. In rhombus RHOM, what is the measure of angle ROH? There is the figure. Okay, so the figure is this one. Now, the given is this angle, which is 35. And you need to find the measure of ROH. So, this angle here. Okay, problem is, the given is from HMO. So how do we solve for this problem? Of course, first is we need to get the measurement of this angle here. So let me erase it first. So we need to get the measure of RMO. So to get that, of course, we need to use theorem number 4. in which a diagonal of a rhombus bisects opposite angles. Therefore, it should be multiplied by 2. So 2 times 35 is 70. Now, by the use, since we will be looking for this, so we need to find also the measurement of this angle by using property number 3, which is consecutive angles are supplementary. So, adding angle RMO and angle MOH should give us 180. Since we have solved for angle RMO as 70 degrees, so substitute. So we have 70 plus 1 plus angle MOH is 180. Transpose 70 to the other side. So we have 180 minus 70. Now what is 180 minus 70? Yes, it's 110 degrees. Now the question is, or the problem is, asking for R, wait, wait for a while. So the problem is asking for this angle. And MOH is the whole part of it. So by theorem 4, MOH is, or ROH is 1/2 of angle MOH. So therefore, all we need to do is just to divide 110 by 2 to get the measure of angle ROH. And it's actually equal to 55 degrees. Okay, problem solved. Okay, another problem is in rectangle KAYE, YO is 18. Find the length of AE. So we have here the figure. So take note that by theorem number 2, AE is equal to KY. Why? Because theorem number 2 states that diagonals of a rectangle are congruent. Alright, so since the given is from KY, therefore we need to find the value of KY. And since we have a given here of 18, so we have to multiply 18 by 2 to get KY. Now 2 times 18 is 36. And if AE is equal to KY, therefore AE is also 36. Okay? Easy. Let's have another problem. The perimeter of a parallelogram is 34 centimeters. If a diagonal is 1 centimeter less than its length and 8 centimeters more than its width, what are the dimensions of this parallelogram? So if this one is the figure and the given is somewhat hidden, so we have to let x to stand as the width of the parallelogram, while y should stand for the length of the parallelogram. And then, since the given is on diagonal, so we have to let d as well to stand for diagonal of the parallelogram. Now, from the given, the first statement is perimeter. Let's go to the next statement. So, diagonal is 1 centimeters less than its length. So, we have diagonal 1 is y, the length is minus 1. So, that's 1 centimeter less than its length here. Wait for a while. So 1 centimeter less than its length. So we have y minus 1. Okay? Now, let's erase it. Another given is diagonal is 8 centimeters more than its width. If our width is x, so we will have diagonal 2 is 8 plus x. And take note that diagonals of a rectangle are congruent. So we can equate diagonal and diagonal 1 and diagonal 2. So from our given, we can substitute d with y minus 1, another d with 8 plus x. So we now have y minus 1 equals 8 plus x. Now let's erase it. Okay, so from there we can transpose negative 1 to the other side. So we have y equals 8 plus x plus 1. Now 8 plus 1 is 9, so we have 9 plus x. Okay, so since the perimeter is given, so we have to use the perimeter formula, which is perimeter of a rectangle is 2 times the length plus the width. Now, by substitution, P here will become 34. Okay? While the length and the width should be this x and y from here. Okay? So the equation would then become 34 equals 2 times x plus y. But since we have y as equal to 9 plus x, so another substitution happens, which is 34 is equal to 2 times the quantity of x. Y here, wait, let me erase them all. Okay, so y here, this y becomes 9 plus x because that's coming from the diagonal formula that we have solved earlier. Now, x plus x is 2x. So the equation would become 34 equals 2 times 2x plus 9. Now, this is multiplication. So we need to distribute 2 to 2x as well as to 9. So 2 times 2x is 4x. This one 4x. And 2 times 9 is 18. So it will become 34 equals 4x plus 18. Now, transpose 18 to the other side there to be combined with 34. So, from positive 18, it will become negative 18. So, 34 minus 18 for a while. 34 minus 18 is 16. So, we have 16 equals 4x. To solve for x, just divide both sides of the equation by 4. So, we have 16 divided by 4. X is equal to 4. And we have here x is the width of the parallelogram. So therefore, this is now our width. Okay? So all we need is just the length because the problem is asking for the dimensions. Okay? So to solve for the length, we have here y as the length and y is 9 plus x. So we can have 9 plus the value of x, which is 4. So 9 plus 4 is 13. Therefore, the length is 4 and the width is 4 rather, and the length is 13. So the dimensions are 4 centimeters and 13 centimeters. Okay, problem solved. Another problem. The diagonal of a rectangle is 4 inches more than the width of the rectangle. If the length is 6 inches, what is the area of the rectangle? First thing that you should do is to create a rectangle. Now, based on the given, 6 is the only thing which has no complications. So we can put 6 right away on the figure. Okay? Now, for the length here, we do not know yet what the length is. So we can let x to stand as the width of the rectangle. Okay? So with that, we can now put x on that side. Let me erase first my writings. Okay, so x is there. And then diagonal of a rectangle is 4 inches more than the width. So if we have x to stand as the width and we have 4 inches more, so we can have x plus 4 or 4 plus x as the diagonal of the rectangle. And since it is the diagonal, so we will place it on the diagonal part. Okay, so we now have x, 6, and x plus 4. Now take note that the figure created based on the given is actually a right triangle. And you have learned already that for right triangles, Pythagorean theorem is very famous, which is the c squared equals a squared plus b squared formula. Now, c is always the diagonal part, so we will put x plus 4 on the part of c, and then either a will be x and b will be 6, or the reverse, 6 and x. They can be interchanged na. So we have here x plus 4 squared equals x squared plus 6x. 6 squared. So that is by substitution. Now when you expand x plus 4, you can do the FOIL. Okay. By multiplying x plus 4 by x plus 4, you will come up with x squared plus 8x plus 16. Okay. So this one, 6 squared is 36. So there you go. Then combine like terms by transposing all x squared there and then 36. So, okay. So let me erase the writings kay Samu. Okay. Okay. So there you go. So now, we will combine like terms. X squared minus x squared is 0. So we do not have x squared anymore. Only 8x. And of course, the difference of 16 and 36. So 16 minus 36 is negative 20. So the equation would be 8x minus 20. Transposing 20 to the other side, we have 8x equals 20. Dividing both by 8, so we have 20 over 8. Now 20 over 8 is can still be reduced to lowest term, which is 5 over 2. So x is 5 halves. When we have here x as the width of the rectangle, therefore we now have the width of the rectangle as 5 over 2, or this is, I think, 2.5 centimeters. However, the problem is not about dimensions. The problem is on the area of the rectangle. So if it is the area of the rectangle, then we need to use the length times width formula. Now, since we have here the width is 5 over 2 and the length is 6 from the given here, so we can have 6 times 5 over 2. Now 6 times 5 is 30 divided by 2, that's 15. So therefore the area of this rectangle is 15 square inches. Okay, problem solved. Another problem. The lengths of the diagonals of a square are given by the expression d plus 1 and 2d minus 5 centimeters. How long are the diagonals? So let's put first a figure and with the diagonals. So let's put also the diagonals, d plus 1 and 2d minus 5. Okay, so how are we going to solve the problem? Since a square is a rectangle, it follows that theorem number 2 of rectangles is applied to the square. And theorem number 2 states that diagonals of a rectangle are congruent. So we can equate d plus 1 or d sub 1 and d sub 2 diagonals. So equating the diagonals, we have d plus 1 equals 2d minus 5. Then transpose, so we have d minus 2d equals negative 5 minus 1. Minus 1, that's coming from the positive 1 here. Transposing it, we'll have negative 1. Now, d minus 2d is negative d. Well, negative 5 minus 1 is negative 6. So we have negative d equal to negative 6. To make it positive, just multiply or divide it by negative 1. So we have d equals 6. The question is, how long are the diagonals? So of course, we need to substitute the d value to the given measurement. So we have d plus 1 is 6 plus 1. So since 6 is the value for d, so we have 7. And since diagonals of a rectangle or a square are congruent, so that follows that the other d is also 6. Let us check. 2d minus 5. So 2 times 6, the value for d is 12 minus 5. So that is still 7. So the diagonals of the square measures 7 centimeters. Okay. Let's have another problem. The length of the sides of a rhombus measures 10. If one diagonal is 8 centimeters long, how long is the other diagonal? So we have here the figure. And then let's put in the given, which is 10. Now we have diagonal. One diagonal is 8 centimeters long. So you have here the 8. Now if this is 8 centimeters, therefore, wait, let me use another color. So if this is 8 centimeters, so therefore 1 is 4, the other one is also 4. Okay, now let me erase it. Oops, I'm sorry. Okay, so take note that theorem 1 of rhombus states that what? Diagonals of a rhombus are perpendicular. Therefore, this one here is a right triangle. Okay, so if that is a right triangle, then we have here, ato siyang kuhaon from the figure. So, we have here the given, which is 10, and D4. Okay, so that's here. This one here and kani. Okay, so what is missing is this figure here. Now, if this is a right triangle, then we can make use of the Pythagorean theorem. And let's say that the unknown variable will be b. Okay, so by substitution, we have diagonal of 10. So c will be substituted with 10. And then we have 10 squared equals 4 squared plus b squared. Now 10 squared is 100 while 4 squared is 16. So we have 100 equals 16 plus b squared. Now transpose 16 to the other side. We have 100 minus 16. What is 100 minus 16? Yes, it's 84. Now, since b squared na siya, so you need to get the square root of 84 to solve for b. And the square root of 84 is, I think this one is divisible by 4. So we have 4 times 21. And the square root of 4 is 2. So the final value for b is 2 square root of 21. The question is, how long is the other diagonal? This b, this one here, wait, let me use another color. Okay, this b here is only this part, diba? This one b, this is just half of this diagonal, diba? Okay, so to get the other, to get the whole part of the diagonal, of course, the solved value for b shall be multiplied by 2. So the measure of the diagonal will be 2 times the value for b, which is 2 square root of 21. Now, by the radicals, all we need is just to multiply outside our coefficients. So we have 2 times 2 is 4. So the final answer is 4 square root of 21. Okay? Problem solved. Okay, so I hope you have learned something about how to solve problems involving properties and theorems on parallelograms, especially special parallelograms. So here is your group assignment. So it's entitled Show More What You've Got. So we have here, solve each problem completely and accurately, meaning you have to show your solutions for every problem. Since we have here the given quadrilateral, which is a parallelogram. So first is if the measure of angle W is equal to x plus 15 and the measure of angle S is 2x plus 5, what is the measure of angle W? Class, you need to remember always that you can only visualize the problem if you're going to draw a figure and then put there the given, okay, so that you will know as to what property are you going to make use of in order to solve the problem. This is actually 1 up to 4, so there you go. So 1 up to 4, so you'll be submitting this, let's have Friday instead of Wednesday, since you'll be having a summative test tomorrow. Okay, good luck. Thank you.